Alright, another day. Let's get into it. Pick one at random. Alright, find pivot index. Given an array of integers called nums, write a method that returns the pivot index of this array. We define the pivot index as the index where the sum of the numbers to the left of the index is equal to the sum of the numbers to the right of the index. If no such index exists, we should return -1. If there are multiple pivot indexes, you should return the leftmost pivot index. Interesting. Let's look at this example. So we have this array, and the output is 3, so that's the index 0, 1, 2, 3. Does it include the pivot? So 5 plus 6, 11. So it doesn't include the pivot, because 7 plus 3, 10, plus 1 is also 11. Okay. Another example. Okay, so this doesn't have 1. It's 1, 1, 3, 0. So I'm guessing you could have negative numbers, which could make it interesting. The arrays are not in order, also making it interesting. Trying to think. I guess, so first of all, the brute force approach would probably be just to test every single pivot. So test every number in the array. So for each element in the array, we then need to test, and we would do that by going through the remaining each side and adding that up and seeing if they're equal. So that essentially would be quadratic time. We should be able to do better than that. Let's look at some notes. The length of nums will be in the range. Okay. Oh, the length. Each element. So the length can be 0 to 10,000, and then each element could be from -1,000 to 1,000. So there are negative numbers. I'm thinking maybe right now I'm thinking maybe having 2 pointers. No, I don't know if that would work. Let me think. So we need to find the pivot. You need to find the location in the array where the left side, the sum of the left side is equal to the sum of the right. Okay, let's I guess what we can do is work off the brute force algorithm that I talked about. So essentially we would say 1. That's our pivot. To the left is 0, and to the right we add up 7, 10, 16, 21, 27. But the thing is, no. I was going to say, if we go past 0, then we know we can stop, but we actually can't because there could be negative numbers, so we would have to test it all. But since we know the sum of these numbers, when we switch to the next pivot, which is 7, we would only have to subtract this number. So we wouldn't have to go through all of the numbers once again. And then for the left side, we would just have to add this number. So essentially we would only have to iterate through. We would be testing each pivot, every element in the array, and then we would also only have to test. We would only have to add up the sum of the whole array once, and then we can just subtract each previous pivot, either subtract or add it to whether it's to the left side or the right side. So I think that still ends up being linear time, which is better than our original brute force algorithm. So let me just summarize that and just think about it a little bit more, seeing if it could end up being the optimal solution. So we have this array. We want to say, okay, first element in the array is the pivot. We add up the sum to the left. There's nothing to the left. And then we add up the sum to the right. In this case, we'll have to go through each element. I guess we would say we could switch on if the sum is 0, since we're just starting. We add up each element. We find the sum. It was 27. Sum is 27 on the right. The sum is 0 on the left. We go to, that's not equal. We go to the next pivot, which is 7. In this case, we just moved pivots. So we say we have the sum still as 27. We say 27, the sum of the left is 0. We say the sum of the left plus the previous plus the previous pivot, which is 1. So the sum of the left is now 1. And then we subtract the current pivot from the right side, so now it's 20. That's not equal. We move on again and keep doing that, and eventually that should work. And it also should give us the leftmost pivot, since we're moving from left to right. So let's go ahead and start to code this. So first of all, we want to say, since the length of nums can be 0, that means we want to say the length, if it's empty, there is no pivot. So we want to just do a guard that is empty. So we want to say if it's not empty, we continue, but if not, we're just going to return -1. We want to do another guard if it's just one number in the array, then that's the pivot, because we have no elements to the left, no elements to The right 0 equals 0. So let's do another guard. Nums.count doesn't equal 1, else we're going to return, or what are we returning? The index, so 0. Okay, now we start. In this case we have an array of 2 or more. Right. So this is where we're going to start to iterate through. But first let's set up our sum variable. Our sum variables left is equal to 0. Right is equal to 0. We have that. What else do we need? Then we can iterate through for we want the index and the number in nums.enumerated. So now we have the index. Let's just go with the index. For I in 0 to up to nums.count, the length of nums. We want to say so this is our pivot. I guess we can call this pivot. Okay, so we have our first pivot 1. So we want to check if the pivot is equal to 0. That means we need to add up. We need to add up the right side, since the left side is going to be 0, the remaining numbers in the array. And we can do that how can we do that the best way? I think we can just start with the right side. We can say just start with the right side and say nums dot reduce it's a little shorthand, just reducing all of them to find the sum of all of the numbers, and then we could take off the first element because that's going to be our pivot. So we can say if left, do we want to check before or after? Yeah, let's check. let's check here. If left doesn't equal right, we're going to continue, but if not, we're going to return 0, the first element as the pivot. And then we're going to say we're going to then move the pivot. So the pivot is now 1. We'll start at 1. So the pivot is now 1. And what we're going to do is say we'll get the previous pivot. No. We'll say left equals the left plus nums pivot minus 1. Right plus minus equals, we're taking away the pivot now. Taking away. So now we have our left and right sum. Now we can check. If left is equal to right, return the pivot. If not, we continue. And if we end up making it to the end and this never executes, then we will return -1. Okay, let's go through this real quick before we run it. So, if the array is empty, there can't be a pivot. Return -1. If the array has one element in it, that means that one element is the pivot, since to the left is 0, to the right is 0, and that's equal. Then we initialize the left sum. We're always going to start on the left, the first element. In this case, always, the left sum is going to be 0. There's nothing to the left. The right sum is going to be the sum of all the numbers in the array. We're going to reduce it to the sum of all numbers minus the current pivot, which is the first element. Then we'll first check if that's equal. The left side is equal to the right side, and if it is, we return 0, the first index, first pivot. If not, we'll continue. So now we're going to increment the pivot. The pivot is now 1. Since we moved it from 0 to 1, we need to add 1 to the left side because it was 0 before. Add the first element to the left side, in this case 1. And then to the right side, we need to subtract the current pivot because that was previously in the sum. And then we can check if the left is equal to the right and return the pivot if it is. If it goes through without the left ever being equal to the right, then we're just going to return -1 because we didn't find it. Let's go ahead and run this. We got the right answer in this test case, and now let's submit it. Alright, runtime 148 milliseconds, faster than 100% of Swift online submissions. Nice job. And so that's going to be it for this one, and I'll catch you guys in the next one.